ASP.NET Web Forms stood the test of time, as it has been around for more than 20 years. Many enterprises are still using it today, and if you find yourself having to develop or maintain applications using ASP.NET Web Forms, then this is the course for you. And in this course, we are going to install Visual Studio, create a new application, work with web forms and web controls, talk about page lifecycle and state management, talk about debugging ASP.NET applications, and last but not least, see how we work with data and SQL Server. So let's get started. In order to get the most out of this course, this is what you should already know. First of all, this is an introductory course, and if you already worked with Visual Studio and with ASP.NET Web Forms for a very long time, that might not be the course for you. If you already have Visual Studio installed on your machine, you might just skip the first chapter, but I still think you would find value looking at some of the parts of this course. Another thing I'm assuming is that you are familiar with Visual Studio. Visual Studio kept the same look and feel for the past almost 30 years, so there is a lot changed. But when it comes to the way you interact with it, is almost the same as it was when it first came out. If you work with Visual Studio Code, I think you would find yourself in a quite familiar territory as well when you come to Visual Studio. So even though you didn't work with Visual Studio, you might find your way around. As well, you should be familiar with HTML. This is not a course about HTML, this is about ASP.NET Web Forms. So if you don't have any familiarity with HTML, I would really recommend to watch other courses that are available on LinkedIn Learning. And last but not least, you should have familiarity with C# and .NET. Again, we are not going to talk about .NET in details, and there are plenty of courses on LinkedIn Learning that you can actually look on C#. So if you do not know any of those two technologies, I really recommend you stop now, go watch those videos, and then come back and watch this one. In this course, we are going to start by installing Visual Studio 2019, and once that would be installed, we are going to create our very first project. And then once the project is created, we are going to explore exactly how the project is built. We are going to add our own controls to it. We are going to interact with the application. We are going to see what's happening when we send the data and how the postback is working. We are going to create our own user controls. And we are even going to connect this application to a database so we can start inserting data to the database. So I can add messages like hello world to my database. And I can press insert, and then we see that a message was added. I can edit the content of the messages inside the database. I can press update, and that gets updated. So this is what we are going to do in this course. So let's get started. The very first thing we need to do is to install Visual Studio on our machines. In order to do that, we need to open a browser and then go to visualstudio.microsoft.com. Now, as you can see here, it says that Visual Studio 2009 is about to be launched. So we are going to record the course using Visual Studio 2009 RC. RC stands for Release Candidate. So we are just a few weeks away from the GA version. So that's why we prefer to work with the version that is very close to the one that you would more likely have to work with. So by pressing this one, we can look here and it says download now. So we can go in and then choose which versions do you want to download. And my recommendation is to go with the community version. Of course, if you have at work already professional or enterprise, then you can do that. But community version is very useful for individual contributors, for open source projects, or for students. So let's press community here. And when we do that, it will automatically take us to a page and says we are going to start the installation process. So we get a small file here. And if I press on that file, it will be open and it will tell me that it needs to update the Visual Studio installer, which we are going to allow. We are okay with that. We say that we want to do the installation, set up the machine as it should. It does some verification and installation of the installer files. And once that this will be done, the proper installer will open and it will allow us to choose what we want to install. So as you can see, we have different kind of installations. So we have different type of workloads. First one, it's the web and cloud, where you have different kind of environment. One for developing web applications, one for developing cloud applications, one for Python, Node.js, and so on. So there are a lot of different kind of workloads. In our case, the only one we need, it's the ASP.NET and web development. Of course, you might need more of those, so If that's your situation, if that's your case, you would have to do that. Another thing that you might actually need to look as well, it's look for the individual components. So for instance, if you want to do something like different targeting for .NET Framework, then you can do that. And I have a recommendation. If you're going to use an older version of .NET Framework, or if you have to use an older version of .NET Framework in your applications, choose .NET Framework 3.5 development tools as well. Okay, so I'm choosing that for completeness, and then I'm pressing install. So the installation and the download will happen at the same time. And I will allow that to run in the background, and I'll come back once the whole installation is done so we can continue with that. So once the installation is done, you might need to restart your machine. So by pressing restart, your machine will get rebooted. So we are going to get back as soon as I'm done with my restarting. So once the computer is restarted, let's go and launch Visual Studio. So what I have to do is look for Visual Studio, and it will show Visual Studio 2019. And the very first choice we have to make is to log in or not. My recommendation is to log in, use either your Microsoft Live ID or your Azure AD account if you have such an account from work. If you don't have, you can create one. And the reason I say you need to create one is because that will save all your changes. So if you are going to use several machines, you get your information sent across, so you don't have to reconfigure Visual Studio every time you open it on a new machine. But for the purpose of this course, I'm not going to sign in and I'm not going to create a user. I'll just choose not now, maybe later. Then the next choice we have to make is what kind of theme do we want to use. So normally the light theme is the one that I would use, especially when I'm doing demos. I've seen a lot of people preferring the dark theme because it doesn't put so much strain on the eyes. So at the end of the day, it's a matter of choice. And even if you don't choose the right one now, you can actually go and change later the themes you chose for your Visual Studio. Another thing we need to choose is what kind of development settings we want. And you can either say, I want Visual C#, for instance, if you are a Visual C# developer, or web development, if you are a web developer, or if you have other languages or other kind of settings, you can choose those. And that has to do with actually how the layout of Visual Studio will look like once you get started, but nothing more. It's no difference. You don't get a different version of Visual Studio just because you choose a different setting there. So by pressing start here, it will prepare Visual Studio for first use. And then once it's done, we are going to see how Visual Studio looks like. So the very first thing here, it's the start screen. The start screen, as you can see, it's very simple, I would say. It got a little bit changed. We start first with cloning or checking out the code. So if you use or your organization already has some kind of repositories, either using SourceSafe or using GitHub or from GitLab or using Azure DevOps, whatever you choose, you can actually press clone and it will automatically get the code from the remote repository and install it on your machine. If you already have on your machine an existing project or solution, you can do that as well by opening this project or solution. If it's an older version of Visual Studio, most likely it will ask you if you are okay with upgrading to the latest version of Visual Studio, which you should say yes. If you have created in the past a website, that would be saved into a local folder. So you can open that local folder and from there you can start editing your existing website. Or you can create a new project, and that's what we are going to do. But before I do that, I just want to show you one more thing. You have a continue without code. So if you don't want to create any project or if you don't want to open any project right now, just want to open Visual Studio and look around, that's what you would do. You would press continue without code. So we have different choices. First one is the language. Then is the platform. I would like to run it on Windows. And then last but not least, that would be a web application that we want to create. So as you can see, we have several options here, and the one that we want is ASP.NET Web Application .NET Framework, not the core web application. Core web application is the newer version of ASP.NET. So let's take this one and press next. Then we get some simple choices, like the name of the application. Let's call it something simple, like Demo App. Where do we want to place it on our machines, and which version of the .NET Framework do we want to use? One thing that I want to draw your attention to, it's the fact that we have .NET Framework 2.0, 3.0, and 3.5 here. And the reason we have them is because when we install, if you recall, I asked you to choose .NET Framework 3.5 tools as well. So that's why we get those here. Anyway, for the purpose of this course, we are going to use .NET Framework 4.7.2. And one more thing I want to add is the fact that you might have a different version, a newer version, because the new version of .NET Framework are coming all the time. So pressing create here, I'll be presented with different choices. And what we are interested here is actually to choose web forms. So if I choose web forms here and I press create, a new project will be created for me, and then I can start working with that one. Before we talk about the structure of our project and what exactly got created, let's first talk about how our application is going to be run. So in order to run our application, we need something called an IIS, Internet Information Server. IIS is an application that runs on a Windows platform, and it will take the request from the client. So this is how it looks. First, the client will send a request to a server. The request itself, it's called an HTTP request. HTTP stands for Hypertext Transfer Protocol. And there can be two types of requests, GET or POST. GET is normally sent when you want to get some data from the server, and POST is used when you want to send some data to the server and then you want the server to process it and then send you back some responses. Now, when the server sees that request, it looks at it, and if it sees that request being an ASP.NET request, it will send it to the .NET framework. The .NET framework will take that request and it will see exactly what it needs to do, maybe getting data from a database, compiling some files, and once it's done with that, it will send the response to the client. If the request is not something that ASP.NET can handle, the server will handle that directly, or it will send it to a different handler for this particular request, and when it gets the response, we'll send the response to the client. While developing our applications, we might not actually need the full version of IIS, so we can use IIS Express. And IIS Express is a lightweight version of IIS that gets automatically installed when you install Visual Studio, so you don't have to do anything about it. Of course, if you are not installing Visual Studio, you can still go and download IIS Express and install it manually. The biggest advantage of using IIS Express is that it does not require admin rights. And the reason you need admin rights is because you need to configure IIS in order to be able to work with your application. And I will show you shortly as well how that installation is done. So there are situations when you are not allowed to run any applications on your machine as an administrator. And if that's the case, then IIS Express is the only way for you to go. Now, there are some limitations. First of all, it does not have support for all the HTTP features, like it cannot work with the Windows Communication Foundation, the services, and it cannot do all the authentication scenarios that you might have. So if you find yourself in a situation when you need the full version of IIS Server, you have to go and do that. And then last but not least, it does not have support for FTP. So again, if you want to have an FTP service installed on the machine that you're running, you might want to install the full IIS server. And next, we are going to look how you install the IIS on your machine. In order to get to work with IIS, we need to install it. So to do that, we go to the Start menu and we write Windows Features. So we have turn Windows features on or off. If you don't find it there, you can just go in the control panel, and inside the control panel, you go to programs and then you choose turn Windows features on or off. One of the features that you might see here, it's actually .NET Framework 3.5, and it's already partly installed, mainly because we chose to install that when we installed Visual Studio. Same goes for .NET Framework Advanced Services. So one of the things we have in here is Internet Information Services. So if I choose that, it will add the services necessary to run my web application. We can expand that and see that we have actually a lot of features that are not installed by default. For instance, we don't get an IIS 6 management compatibility, and you won't need that anymore unless you have a very old installation of IIS and you want to use those kind of older tools. If you want to control IIS via tools, you can use that. And as well, if you want to manage IIS from a different machine, you can choose that as well. So in a production environment, for instance, you might want to install those services because you want to manage them not from the machine itself, but from a management server that would be available in your network. Other features that we have here and they're not turned on by default are sub-features of those. Like if you want to do extensibility on .NET Framework 3.5, support for ASP.NET 3.5 and 4.7 as part of your IIS installation. They are already installed on your machine as part of Visual Studio, but IIS won't support them if we are not turning them on. We have support for different security protocols, for instance, that might be as well of interest. If my application needs to deal with security, if I want to test it exactly how it will work in production, I can choose other features here. So again, depending on what exactly your application needs to do, if you want to be able to test it locally, you would choose those as well. If you want to have support for content compression, static content compression is on by default, dynamic only if you choose so. And again, this has to do with optimizing the traffic that gets sent back and forth on the network. And then we have health and diagnostics. Again, if we want to send logging somewhere, by default, we get all the HTTP logging. But if we want to send the logs to a custom source or have some logging tools installed or support for tracing inside IIS, then we can add that as well. And some of the common HTTP features like redirection and WebDAV publishing are not installed by default. But if I want to have that possibility, then I can choose that. WebDAV is not used anymore. It's an older technology that was used with front page. I wouldn't worry too much about it. Once I'm done with that, I press OK. And then Windows will start to gather all the information. It will look if the files are present locally. And if they are there, it would install them. If not, it will take them from Windows Update Server. Once this is done, it might be necessary to restart the machine. Because we had already .NET Framework installed and we restarted the machine earlier, we don't need to do it now. And pressing close, it means we have already IIS installed. Just to show what we got, if we go in here now and we press IIS, we have an IIS Information Services Manager, which is the manager itself, and that will show us this is the machine name and those are the sites that are available here. So we have a default website with a lot of .NET settings that we can change from here or we can change from our application. There is no need for us to go into details. I just want to show you that this is here. If you want to see more about the IIS and how you can automate the installation and all other features, there are several courses on LinkedIn Learning that you can access and get this information. So now that we've seen how an application is run, we are back in Visual Studio. So if I want to run this particular project, I have several options. So first one is actually I can press here and I will run that directly. It's in IIS Express and it will start Google Chrome as my browser. If I want to choose a different browser, I can go in here and choose a different browser. The reason it shows Google Chrome here is because this is my default browser on this current machine. If I want to run the application in IIS, I have to actually go in here and change the project itself, change the properties of the project. However, I won't be able to do that directly, mainly because if I choose this one here, it will tell me that it will create a new project URL called demo app. But if I press create virtual directory, it will give me an error telling me that I am not an administrator on this particular machine. So if I want to do that, I need to run Visual Studio as an administrator, which I won't be doing. I just wanted to show you how you can change the server if you want to run that. If you did not install IIS, you won't see local IIS on this drop-down list. If I want to run Visual Studio as an administrator, I'll have to go to Start, write Visual Studio, and then on the Visual Studio, I can see here on the right-hand side that I have run as administrator. If this one doesn't show, you might have a drop-down here, or you might right-click on this one and choose Run as an administrator. But now I have it, so I can just put Run as administrator. When I do that, it will ask me for my permission. I say yes, and then I can say continue without a code because I don't really need to have a code. But I have an indication here that this is run as an administrator. Just a reminder, because I'm running a release candidate, that's why it says RC. Once the GA is available, the RC will disappear from here. So let's close that down and go back to our project. So I don't need to do any changes here. I would leave it as is, and we can close this page. So let's see what happens if I run the application. I press in here then, and it will automatically start Internet Information Server Express Edition, and it will start listening to the port 63826. And I have a very simple application that has 3 pages, a home page, an about page, and a contact page. We have as well here application name, which we can change actually and give it a more meaningful name. For instance, I will go and show you in a minute how we can call this one demo application, because that's what it is. Before we explore the project structure, let's have a quick look at Visual Studio and the development environment that we are using. So there are few things that would be of interest. First of all, view. In the view, you get a lot of windows that you can open and will help you with different aspects of your application development. So whenever you need to open a window, look if it's here. If you don't see it here, look in other windows, because those definitely will give you what you actually need inside your project. The second menu of importance is actually build. So we have several here. One of them is build solution. So build solution, it means that we'll take every single project in this current solution and it will build it. Now, sometimes you might want to do a rebuild. Rebuild means that you remove everything that was built before and then you build a solution from scratch. That's in practice cleaning the solution, meaning removing all the intermediary files and doing a build of your solution. Now, if you don't want to build the whole solution, you can just go and do a build of a project. So you can build individual projects out of it. Now, keep in mind, even if you choose build project, it might actually build more than just current project if there are dependencies on other projects that has been updated. The reason you might want to do that is because you have a very big solution with maybe, tenths or hundreds of projects, and you don't want to build everything because that might take a little bit of time. And the same goes for rebuild demo app and clean demo app. Again, this only will do a build or a rebuild of a current project and only its dependencies. Then we have publish. We are going to talk about publish a little bit later at the end of the course, and I will show you how you can quickly publish your application somewhere. This is not a course about the web deployment. It's only about to show publishing in the context of this course. And then we have debugging. I show you how you can press the button in the main screen, here where you say, I want to run the IIS Express with Google Chrome. But if you want to do debugging from the menu, start debugging or pressing F5 would do exactly the same thing. If you don't want to do any debugging because you might want to see exactly how quick the application is loading and you don't want to run it inside Visual Studio, you can press Ctrl F5 or start without debugging. And again, I think that it's more or less what we need to know at the moment. The rest of the things we are going to cover a little bit later inside the course. The last part that I would show you is how you can change certain aspects of your editor. So if you go to Tool Options, you get to see the options of your editor. So first one, it's the color theme. If you want to change it from light to something else, that's where you do it. And there are actually extra themes that you can install. In our case, we just have the default ones. One thing that I would like to change before we get started, it's the size of the font. So I want to go from 10 to 18 just so we get to see better the text on the screen. So what I have to do is just go into fonts and colors and choose that here and choose 18 as a font. And once I press OK, now my Visual Studio environment would be changed. So the size of the files, for instance, if I take any of those files in here, will be 18. So I'll get to see a little bit better on the screen. So let's have a look at the project structure. And let's start from the top. First, we have the app data folder. At the moment, it's empty. But in this folder, you would place your local database files. And this is the only folder where your application has the rights, meaning that you can write files in that, you can modify files that are in that folder. Everything else, you have only read rights. Then we have the app start folder. In the app start folder, we have two files at the moment, bundle config and route config. I'm going to touch them in a minute. Then we have content. Here we have all the CSS files that are going to deal with the look and feel of our application. Then we have the fonts folder. In that, if you need any custom fonts for your application, that's where they will have to reside. And last but not least, we have the scripts folder. And in this one, we have all the JavaScript files that your application or your ASPX files might need. Next, we have the web config. And the web config is actually responsible for configuring our web application. And what we are going to work with in general, it's only the system web part. So what we are going to see here. Of course, we are going to add other sections in this one, but at the moment we have only this about compilation and HTTP runtime and some how we can configure the pages. What normally gets added in here are stuff like connection strings, application settings. So there are a lot of things that can be added here. And again, we are going to watch them or look at them during this course. And last but not least, when we talk about general look and feel of the application, we have global assets. Global assets is a very important file because it contains code that will affect the whole application. So in our case, at the moment, we have only one single method called application start. This method gets invoked every single time we start our application. And what that means, it means that if I start the application for the first time, or if IIS has to restart my application, this method will get invoked. And it does two things at the moment. One, it's to register the routes, and the other one to register the bundles. And if you remember, there are two files that I mentioned, they will get invoked at the beginning. And register routes is actually a method inside the route config file. So I have this, the register routes method. And then the second one, it's register bundles, which resides in bundle config files. And this is where the bundles get registered. Again, we are going to talk a little bit later in details about what exactly do you put in here and how do they get moved into your application. Next, let's have a look at how the content of the application gets created. And the first thing we have here is Site Master. Site Master is a so-called layout page. And this is where all the information about how the site should look and feel resides. So we have the HTML tag, and then we have the head tag, which contains the meta and the title. And we have some script informations in here. And we are including as well the bundle reference. So if you remember, I said that we have bundle config. This is where it gets rendered on the page. Then we have a link where we include the favorite icon for the page, which will show a small icon whenever you open the page inside any browser that you want to use it. And then we have the body of our page. And we start with a simple form. And I'm going to cover why do we need the form in the next module. Then we have the scripts that will be used on the file. And then we have the layout itself, the information about the page. So we are going to start with the navigation bar. Inside the navigation bar, we have a branding information. So that one we can go and change. So from application name, we can call it now demo app. And then we have the links that we want to have for the particular page. We have a home link, an about, and a contact page. And then we have the content of the page itself. And we have one content placeholder. Again, we are going to talk a bit more about content placeholder later in this course, but right now suffice to say that here is where every single page places its content. And then we have the footer of the page. And that's about it. Now, let's have a look at a simple content page. So let's take about ASPX because this is the simplest one of them. And it has a content control that works together with the content placeholder that has the ID of main content. And what it will do, it will replace that particular content placeholder with exactly this content. And the same does contact ASPX and default ASPX. So there is no difference whatsoever. So now if we go back to about ASPX and we run the application, we are going to see exactly how this one looks like. So once the about page is loaded, let's have a look at the page source and see exactly where all the things are. So if you remember, we had a doctype HTML, we have the HTML tag. So here you can see all the things that were part of the site master. And down here we can see we have the nav bar, we have all the links in here. And where the content is, the content placeholder got replaced actually with the about content. And again, if we move to any other pages, we will see that everything else is the same except that particular content. So let's get started to look into how ASPX actually works. And I'm going to open the ASPX page. We've seen that before, but we only touched the content part of it and that it gets replaced inside the site master page. So let's look at the page itself. How does it look like? First of all, we start with something called a page directive. So every single ASPX page will start with a page directive. And there are several ones. One of them is called the page directive. There is another one called namespaces. There is another one called include and assemblies. But for the sake of brevity, we are only going to talk about the page directive in here. So the first thing we have a property called title. And as you can see, this one is set to about. That means that inside my current page, I will have a variable called title that will contain the text about. Then I specify the language of this particular page. Then I specify which master page files should I use. So that's where actually the master page comes into place. We have here the site master. So this is the page that we are talking about. Then we have a property called auto event wire up. Auto event wire up it's nothing more than just a way for me to say that there are some events on the page that I want you to automatically try to identify them. And I will show you one in just a minute, so just keep this in mind. And the next part we have the code behind file, which is about.aspx.cs, which means that if I want to connect this page with the code behind file, the information will be in this particular CS file. And then last but not least, we have an inherit, which says from which base class we are inheriting. So let me show you quickly the CS file, although we are going to talk in detail in the next chapter, and show you that we have here a file called about.aspx.cs, and inside it we have a class called demoapp.about. So that's how those two are connected. Now, what ASP.NET does, whenever it sees an ASPX page, it will automatically generate a C# file. I know it might sound a little bit counterintuitive, especially when we see here stuff that look like HTML and they would be generated as HTML. But the way it works is that it takes information that it finds in here and it will convert it in C# code. So one of the things, for instance, when it encounters this ASP::content, ASP::content has an interesting attribute called run@server. This run@server attribute, it says to ASP.NET that please treat that as a non-HTML piece of code and treat it actually as a control that you can work with. And because it has the run@server, now ASP.NET knows to connect this one with what we saw earlier in the site master file. The next part is this one. It says h2, and for this one it will just say take this h2 and generate code, and actually the code generated would be something along those lines, response.write, and it will write the text as is. The next thing it will encounter will be this less than % and colon. What that does, it will take the variable title that we set up here actually to the value about, and it will say please encode that one and write it to the output. And then it sees this, which is actually text from here to here, and with all of this it would just say again response.write. Now when we talk about those, there are different other directives that are available for us to use. Another directive would be this one, equal. So equal does the same thing at colon, but it does not do encoding. Encoding means that if I put an HTML tag in this one, it will automatically put it as is. So if I put encoding like this, it will transfer that and it will just write the text as is. I will show you shortly a demo exactly how that is done. And one more thing that we have a code directive. So if I write something like this, I can write direct C# code inside this particular page. And the reason it knows it's C# is because I added here language C#. So then I can do something like title equals, and then instead of having the about title, I will override the value with something from code. Okay? And this being a normal C# code, I have to put a semicolon. And if I run the application now, I will see that on the ASPX page, my title would not be about anymore, it would be from code. As you can see, now we have from code. And just to show you how the difference between encoding and non-encoding, if I put that now to be an equal and I save it and I refresh the page, it will still show me the code. But if I go now and change from code to something along the line, let's do I, so that's an italic, like this, and then I save it, and then I do a refresh, then from code would be italic. And if I go back here and then put again the colon, and I save it, and I refresh the page, then it will show me the text as is, meaning that it would do an HTML encoding. Be aware that if you use HTML directly on the page, you might actually make your site susceptible to script injection, meaning that if I put an HTML that contains the JavaScript, then it would automatically be run on the page if that is not encoded. So we've seen how an ASPX page looks like. Let's talk about some of the elements that we saw on that particular page. Of course, most of it looks like an HTML. And as I pointed out on the page itself, some of it is HTML, some of it just looks like HTML, which means it's an ASP.NET code that is inside that particular page. So let's see some common syntax elements that we are going to find on every single page. At the top of a page, we are going to find the page directives or the preprocessor directives, whichever you want to call. And then those preprocessor directives that we have could be a page directive, meaning that we specify the language, we specify the title, as we already saw in the previous video. Then we have stuff like register, where we can actually register different user controls on the page. We have namespaces if we want to bring namespaces in that page when we want to use it with code. And there are several others. So if you're really interested, just look for the page directives and then you'll see each and every one of them that you have available there. The next one we have the controls. So we saw that we have something like less than ESP colon and then some control names. In our case was a button, for instance, that we could add, or we had actually a control placeholder. And one key element of that particular control was the directive called run at server. So inside that we had a run at attribute and the value was server. It has to be ad literam, so you can't change, you can't say run at client, that would give you an error. So run at server, what that means, it indicates for the ASP.NET preprocessor that this particular element in here needs special treatment. So it will be sent to the preprocessor and it will actually look for a control called some control. Now ASP colon, it's a prefix, and the prefix, it is registered in such a way that ASP.NET knows to look for a control called some control in a specific namespace. In our case would be system.web.ui.web controls. So that's where it will find the information about that control. And then when I have the first ... in there, I can add different properties that I want to set for this particular control. Then on the second one, if the control gets some content, then I can put it in there. And again, the ASP.NET processor will use that content for whatever it needs to use it. The next one, it's the inline code. So inline code, it means that I can add C# code and I can make decision trees, I can add actually if and for's and so on inside the ASPX page. However, this is not recommended practice, as I mentioned earlier, because this can lead to the so-called spaghetti code. Then we have less than %equal directive. This will write the content of it straight to the response stream. So what I put in there, I put a variable. So what it will do behind the curtains, it will call the toString method of that particular variable. Or if it's a method, it will take the result of that method invocation and it will call toString on it, and it will just write it straight to the client as is. Now, sometimes we don't want to write it as is, we want to have it encoded just because we want to make sure that we don't get any script injections, or I want to make sure that we clean up the data that we are sending. So for that reason, we need to use encoding. So instead of putting equal, we're putting colon, and the result would be the same. Other directives that are available for us, it's the $directive. It's useful for expression evaluation. So if you have stuff that you want to save in a resource file, or if you want to look for stuff inside your application settings or on your connection strings, those are special expressions that can be evaluated in the ASPX page. The next two have to do with data binding. Data binding is when we work with the data, we can actually bind the content straight to a field in a database. And that would be a two-way connection, so we don't have to think about writing or reading the data from there. It would be automatically done by the ASP.NET on our behalf. So the first one is not normal data binding. The second one, the one with the colon, would be the encoded data binding. And last but not least, we have comments. So if I want to comment out a piece of ASPX code, then I can use less than %, and then when I want to end the comment, I would use %, bigger than. And that's it. So next up, let's talk about code behind files. But before we do that, let's remove what we've added here so we don't have any code that will change what we are doing. And as I mentioned, the connection between the code behind files and the ASPX, it's done here. It says that the code behind file should be about.aspx.cs and that we are going to inherit from the demo app.about class. So going back here, we see that already we have a page_load. And page_load will be automatically invoked when the page is getting loaded. At the end of this module, I'm going to go through the whole page lifecycle where page load would be mentioned as well. So let's do something else in here. So we saw that we can add code on the ASPX file. Now, there is one reason we would want to avoid this, mainly because this would create a so-called spaghetti code feeling. If I'm going in the ASPX file and I'm adding the code that I need or that I want to have, it might create some problems in the future, especially if I want to maintain the code. So what I can do now, I can go in the page behind and I would say, please, let's do that. And I want to change the title in here. Now, remember, the title is already there because it is a part of the page class definition. So this about page that I'm creating, it's inheriting from system.web.ui.page, which is a base class for all the pages that we are going to encounter inside ASP.NET Web Forms applications. So I can say title, it's equals with from code behind. So we know that where the title is coming from. So if I go now and then run the application again, like this, we are going to see that we have automatically generated the title to be from code behind. So it's not the one at the top. Okay, so let's close that and go back to the code. So why is that important? Well, every time when you add something in here inside this, like a control or something that needs interaction with the code behind, the interaction itself should happen in here. And you're going to see in the next module that when we add, for instance, a control would be automatically connected to this inside the page. Now, there is one more piece of code that is of interest for us here, and that's the about.aspx.designer.cs file. This is a partial class about. Now, if we read very carefully what it says here, this is an auto-generated file. This was generated by a tool, and you should not change that manually because that can lead to unexpected behavior. This class and this class are the same. So both being partial classes, it means that ASP.NET would combine them into one single class. So when I'm adding a control, for instance, in this page, the control definition would end up in the designer page, while the interaction with it would happen in the class in here, in this page. So next, let's start talking about web controls. So ASP.NET Web Form comes with a lot of predefined controls that you can just use in your page. One example is the ASP content control. Many of them are those that we can see here. We have standard controls where we can use a pointer, we can use a rotator, buttons, calendars, multi-view, substitution, views, labels. So there are a lot of controls that are predefined. If we want to work with data, again, we have a lot of controls that we can use for the data. We have a validation control that we can work with, compare validator, custom validator. So we are using that in order to validate data we put in a data form. We have navigation like menu and 3-view and sitemap and so on and so on. So there are many controls that come out of the box and predefined for your application. Another one we have here is the web form, which is the bundle reference. And the reason this one shows up here is because we use that in our master page. So that's why you would get this one as well on your page. So let's see how we can use that. Well, first of all, we can go in here and we can take whatever control we want. So let's do a button and then we can drag it somewhere on the page. And what it will do, it will put the hypertext necessary or the markup necessary to have this control. However, I don't want to do it this way. I want to show you a different way to do it. And that's by using the design view. So by using the design view, I get actually a chance to place the button wherever I want on the screen. And getting a what you see, it's what you get kind of feeling. So I know exactly where this one would end up. So if I put it like this, I will have exactly the same result. But if I want to put it on a different line, I can just go back here and press enter. And then it would automatically be placed on a different line. Now, this button has some properties. In order for me to see the properties, I will right click on the button and choose properties here. One of the properties is the text. So I want to change the text to send info. And as soon as I leave that, you would see that the text on the button got changed as well. Another thing I want to change is actually the ID of the button. Button 1 doesn't say too much. So I really want to make sure that if I work with it inside my code, I would know which button we are talking about. So it would be send info button. And the recommendation is that you are using different names for different controls, and maybe you are consistent when you use the labels or the prefix for those particular controls. So btn for buttons, lbl for labels, txt for text boxes, and so on and so on. So now that I'm done with that, I can save it. And I can show you, if you remember, I mentioned earlier that all the things are actually ending up being inside the designer file. So here what I got now, automatically generated field, it's a button web control called btn send info. So let's go back to the ASPX page, and we have again the property window here, but now it's a little bit minimized. So inside here, instead of looking at the properties, we can look at the events. And one of the events we have here is click. By double clicking on this field here, it will automatically create a method call for me, btn send info underscore click. If I go back in here and I'm looking at the source code, you will see that I have an onClick event connected to btn send info underscore click method. So let's see, if I get this and I would say title equals button was clicked, then whenever I click the button, the page should change appearance. So let's try again and see exactly how that looks. And if I press send info, you would see here that button was clicked. So far we have seen how we can interact with a button that we put on a page, but this is a very simple case. So let's see how we can make it a little bit more advanced. And what I'm planning to do now is to actually add a text box on this particular page. So what I will go now, I will go in the toolbox and I can take a text box and I can drag it on this page. So let's do that. Of course, I can do that either on the source code or I can do it on the design. And one thing that we have extra here is actually the split window. So with a split window, I can actually split the windows into two. I can have the source code in here, or I can have the design view in here. I get a warning telling me that it's out of sync. So if I want to synchronize, I need to press this and it will show me now that the text box as well is part of this page. So I have now those two in sync. So I can change in either part. I can change in here, for instance, and I can right click and say properties. Then I can go inside the properties and see the properties that can be changed. One of them being the ID. So let's do that and change the txt data. And if I leave the field, you will see that this one gets updated automatically. So it's pretty straightforward. Now we can use the information that we put in the text box inside on the code behind. So let's go in the code behind now. And I don't really need to have this one here because I want to work inside my page load. Now, when you load a page as a response to an event that happened on the web page, like sending a button, one property is set, and that property is called postback. If you remember, I mentioned at the beginning of this course when we were talking about the IIS that there are two kinds of messages. One message that is called get and one that is called post. So whenever I'm pressing a button, the information on that page is sent back to the server, and the method used is a post method. So whenever this is postback it's set, it means that we are sending data from the client to the server. So of course, if I want to show the title like this when it's not a postback, I'll put if it's not postback. Else, I want to handle that in a different way. So I would say title now equals, and I would say postback data. So what data do we write in there? And then I would add the txt data.text. So what that means, it means that I'm reading the text property of the text box control. If we go back in the designer, we are going to see that we have another control here now called the txt data of the type text box. And saving everything and running the application, we are going to see the result. So as you see, we have the from code behind, but if I put now something in here like hello world, and I press send info, we're going to see postback data hello world. So one thing that I want to talk about with you right now is about ASP.NET page lifecycle. And what that means, it means what is happening while we are running a page, when a page gets loaded by ASP.NET Framework. So let's have a look at it. We have three distinct phases. The first one is called the init phase. And in that phase, we are actually going to initialize the page. Then we have the load phase. And then last but not least, we have the render phase. And let's talk about each and every one of them and what exactly happens behind the curtains. So when we start with the pre-init, what we are actually going to do is we are going to prepare the page, meaning that every single control is going to get created. And then once this is done, the pre-init event is going to happen. So in our case, if we have a method called page_pre-init, that method would get called. The next event that would happen would be init, and in that one we are going to initialize and maybe add some start data inside our controls. And again, if we have a page_init method, that method would get called inside the page. Next up is the init complete, meaning that we managed to call init method on the page and then all the other controls that have been on the page, and now we are done with that, and then it's a marker for ASP.NET that this got completed. And with that one, we get to transition to the next phase, which is the load phase. Now, in between those two phases, if we happen to make a postback, that's when some of the postback data gets loaded. However, we are going to talk more in details about the data and how that gets handled when we are going to talk about managing states in the next module. So inside the load phase, again, we have a preload, which means we want to prepare the controls to get loaded with the data, either from a database or from whatever we want to get the data, or with the data that we got from the postback. Then we have the load message itself, where it says, now we have all the control trees built, we have put all the postback data and all the information. Then we load the page. And once the page is loaded, we can run load complete. And then it comes the render phase. Again, in between load phase and render phase, what would happen, we'll get all the change messages. So if we change something in a text box, that would get handled here. If we press a button, the submit of that particular button will get handled here. And when that is done, we go into that particular render phase. So render phase then, again, has three distinct phases, one of them being pre-render. It means that now we got more or less everything that we need, and we want to do some small tweaks, some small changes to that. And then it's an important part which is called the pre-render complete. Pre-render complete plays a very interesting role in a page. And that is when you run asynchronous code, meaning that you want to run something outside the control of your page, on the pre-render complete, you would get back the control if anything was asynchronous. However, this is outside of the scope of this course. I just want to mention so you know the meaning of this particular event. So it is important. Once the pre-render is complete, what would happen behind the curtains is that ASP.NET will save the state. Again, we are going to look into details in next module on the state. And once that is done, it will call the render method. Now, when the render method gets called, that's the end of it. You cannot change anything because at that point in time, all the data and all the HTML that got generated by ASP would be sent to the client. One of the most important aspects of software development lifecycle, it's not actually developing the application, it's maintaining the application. And as developers, we tend to forget that. If you look at the lifetime of an application, about 20% of the time it's spent developing that application, and about 80% it's spent maintaining that particular application. So writing maintainable code, it's a very important aspect of the software development lifecycle. Now, when we talk about creating maintainable code, there are three different phases that we can think of. The first phase, it's called designing. So what I mean by designing is actually it's an active process that you have to do in order to decide what is important for your application and what exactly do you want to save out of this application and the way the application is running, where exactly do you want to save the information about the application, and so on. The second phase, it's called instrumenting. So when we talk about instrumenting, we have actually different ways of instrumenting our code. The most common ones would be logging. So logging is the process of you going inside your code and writing to a file or to a database or to something that something was happening inside your application. The other one is tracing. Tracing means that I would actually be able to trace what happens inside my application, like how long it takes to execute a certain method, which methods get invoked, in which order, and so on and so on. The third one, it's debugging. So debugging is the process of actually going and actively trying to understand how your application runs. And debugging normally happens at development time. Of course, you can debug production applications, but that's happening mostly when you have very convoluted or very complex bugs that you did not discover while you were developing your application. Another one is profiling. So profiling will give you information of how the application behaves in different scenarios. For instance, if you have a lot of load inside your application, or if you have a lot of users accessing your application, and so on. And last but not least is performance monitoring. And again, it has to do with how well your users are served in normal circumstances. So you want to monitor the performance of your application so you can make sure that your application fulfills its duties. And Last but not least, we have using of that information, use of the instrumentation that we are doing. And the way we do that is actually by using different monitoring tools, either the ones built in Windows or in Azure if you deploy in Azure, or whatever platform you choose to use. You can do that by analyzing logs. So you can look actually at the logs inside your application, and then you can see what was happening. And maybe based on that, you can either improve your application or you can detect where something went wrong. And you can use that as well to create alerts. So for instance, you can say, based on performance monitoring rules, if the CPU goes over a certain threshold, then I want to get an email telling me that something is wrong there. Or if I see that I get way too many errors in a very short period of time, then I might as well send a mail or an SMS or something like that to inform someone about the state of the application. And again, we want to do that in order to make sure that the application is easier to be maintained and it's easier to operate. One way to get a better understanding of what happens with a page is to use something called tracing. And we have two different levels where we can do tracing. We can do it at page level or we can do it at application level. So let's see first at page level. I can go here and in the page directive, I can just go in and add trace. And then the value it can take, it's true or false. So if I say trace equals true, and when I run the application, it will automatically show me a list of all the events that are happening while I'm running this particular page. So if I look in here, I can see that I got first a pre-init and then the init and init completed. Then we get the preloaded load and load complete, pre-render, save state, and render. Of course, we get information about all the controls and the control trees, how the controls are actually placed inside this particular page. We get information about session, application, if we have any cookies and so on. So everything, it is specified at the bottom of this page. This can be very valuable information, especially when you have strange errors or when you want to understand what exactly is happening inside your application. Let's try and see what happens when I press this. If I say now send info with a hello world, I will get again the pre-init, init complete, but now I start to get load state, process post data, preload, load, and then we do a second try on the process post data. Then we look at all the change event, postback events, and then load complete, pre-render complete, save state complete, and pre-render. So of course, this can be actually annoying, so I don't want to see that every time I run my application or every time I look on a particular page. So one thing I could do instead, I can remove the trace from here, and then I can enable it per application. And in order for me to do that, I need to go into web config, and inside the system.web configuration section, I need to add another section called trace. And trace has different properties. One of them is enabled, and I would say true. What that will do, it will enable tracing for my whole application, meaning that every single time when I'm invoking a page or when I'm posting data, tracing information would be saved. However, it won't be shown on the page. Another thing that I recommend you to do is actually to set local only to true, meaning that you only get access to this if you are on the local machine. And the reason I'm saying that is because quite often you might forget removing that when you put your application in production, and you don't want everyone to get access to all this information about your application. So if we run again the application now, we are going to see that we have the home page. I will show you as well the about page, just to see that there is nothing there, so the page is clean. But then I have a hidden page, I would say, which is at my site, and then it's trace.axd. If I press on that one, it will show all the requests that were happening in my application so far, one of them being for the about file. So if I press the view details here, I get to see the exact details. Let's go back and then let's try again and say hello world, send info. And now if I go and do a refresh on this page, I will get the postback that we had on this particular page. And the information is exactly similar with the one that we had on the about page when we were pressing the button. So far we've seen how we can add actually tracing for our application. But let's see how we can do actually and that trace from our code. And it's a very simple way of doing that. We have an object called trace, and that trace object has a method called write. The method has actually 3 different overloads, but one that is very interesting for us is actually this one, where we have a category. So the category would be from code. And then another one would be the message that we want to convey. So we are going to say this is a no postback. The name of the category could be whatever you want, so we are not actually bound to use the name from code or whatever. I just chose this name because it made a little bit more sense. And then I can see here we have a postback, and then I can add the text data.text txt data.text as a data, so I get to see exactly what is on the screen. So let's do like this. Now, if we run the application again, and we do a postback with a hello world, and I will say send info, we should already have now two different traces. So let's do again localhost and then load the trace.ext file. As you can see, we have two different traces. And if we look in the first one, we have from code no postback. And then if we go back and look in the second one, we have again from code, but then we have postback and hello world in here. Sometimes when we run our applications, errors could happen. And if we expect those, then we can actually handle them gracefully. But sometimes we are not expecting some errors to happen. And in that case, we're calling them exceptions. So let me give you an example. Let's assume that you want to read something from the database, and all of a sudden the database server is not responding because it's down or you don't have a network connection. And that's an exception. So sometimes your application might be ready to handle these kind of situations. Sometimes it might not. So when you're ready to handle those, then you can actually handle the exceptions. But if not, it is important to report those kind of exceptions. However, in our application, because it's pretty simple, I don't really have something that can generate an exception, so I'll do that by myself. So what I've done here, I created a simple call inside my button sendinfo_click. So what I'm saying here is that if the txt data, it's either empty or it's a white space one, then I will throw an application exception, just like that. So this will correspond maybe to calling a database, and the code that you are invoking to call the database will throw a certain exception. So let's see how this one actually works. So I can go in here and I can run the application. Once the application is up, I can press the send info button. Now, because I'm running that in debug mode, this will automatically get started inside Visual Studio, giving me a chance to actually investigate what was happening. So of course now I know what happens, because if I look here, I get to see that the txt data.text, it's actually an empty box. If I press continue in here, what I get is the so-called yellow text of death. The nice part of the yellow text of death is actually, it shows me where that error has happened. Plus that it gives me some information. If you look in here, it says something unthinkable happened. So this can be actually very useful even if you don't have a debugger. Let me show that again without running in debugging mode. So what I will do now, I would say debug, start without debugging. And the same application would get run. If I press send info, instead of stopping inside the debugger, inside Visual Studio, it will go straight to this particular yellow screen of death. Now, of course, this can actually give information that is not really okay to give it to outside people. So we might want to actually hide this. So in order for us to be able to hide this information, we have to go in the web config. So inside web config, we have another configuration that we need to put in, which is called custom errors. So custom errors has different modes, and we want to put it in the mode on. Now, by default, it's off. If I put it in mode on, it means that automatically it will show me custom error pages, and I can make a choice per page. So I can say if the error number or if the status code it's 404, then we can redirect to a page. This is not the page you are looking for, something like that, .aspx. I don't have that page, but I think you get the idea. You can create a page for a specific per status code. If I want to get the information about the detailed information about the error, instead of putting on, I can put remote only, meaning that if someone comes from another machine, we'll get those status codes, but if I'm running it on the same machine, then I will get the original error message. So let's see the difference now. If I run the application again, and maybe I should have run it without debugging, but now it's too late. And go to About page and press Send Info. Again, it stops inside Visual Studio, but now it gives me direct the information that says something wrong happened. I don't know what happened. I can't show you what happened, but if you want to see, then you need to change the custom error mode either to remote only or to set it to off as it is indicated here. So that's why we get this kind of information. So we've seen how you can handle exceptions generally, how you can configure your application to handle exceptions, either to show you the exception that was thrown or to actually show you a custom error page in case that happens. But it's not really handling, it's just offering the information to the user. So let's see what are our options to handle exceptions. Well, if we know the kind of exception or if we expect some kind of exceptions, we can use a try-catch block. So in our case, if we would expect that this could be an empty string, I would have had a try and catch block around it. And if I would have caught this application exception, and instead of crashing the whole application, I would have just gone and say, please fix that error or do something about it. Now, when I say crashing the whole application, I'm not crashing the IIS, I'm just crashing the current request that I'm making to the server. So I can always go back to the previous page and get the data that I had before. So that's not really crashing the application. But this means that we need to know or to understand exactly when something happens and how we can treat it on this place. But sometimes we might not know, and we want to make sure that we save the information about the errors when those errors happen. So one thing we can do here, we can actually go here and say, let's add this piece of code. So what we do here, I'm uncommenting the page, so either pressing the uncomment button or pressing the Ctrl-K-U, so I remove all the comments on this particular code. And I have a method called page error. If you remember, I told you here that in about ASPX, I have auto event wire up set to true, and that there are some methods inside that page that get automatically called. And one of them is this page error. So what I can do here, I can either log the information somewhere, or I can actually get the information about the error itself and run with it. Now, by calling server clear error, that means that I would automatically say to the server, please do not report that any further. Now, if I don't say that, then I wouldn't actually get the response.writeX message at all in here. So let me run the application just to show you how it looks like. When I run this application, I'm going back into the About page. And now if I press Send Info, I will get something unthinkable happen, meaning that I managed the exception by myself. Without the clear error here, what I would have got would have been back to the yellow screen of death that I had earlier, so I would never get a chance to see that. So this is handling the error at the page level. Then we have a different level, which is an application level. So at the application level, I would have another method. In this case, would be called void application underscore error with the same signature like the one above here. And then I can actually save the message. I can say again server.getLastError. And then once I have the error var ex, I can send this particular error to a log file. And then I would have the information. Now, if you think about it, now I'm at application level, so I don't have any response anymore because the application has no idea about the response. This is something of a last resource, I would say, when I get a chance to save the information. So you should prepare your application for errors like this or putting the stuff in a page. But in most cases, you should actually be able to handle the exceptions when they happen. I know that you don't write bugs, and neither do I, but what happens when the misfortune just happened and we do write some of them? How can we fix that? One way to do it is actually to start understanding the application when we are developing it and to try to look exactly how it behaves at runtimes. And in order for us to understand this behavior, we need to be able to stop inside our application. So let's assume that I identified somehow that my error would happen around this point in here. And let me hide the Solution Explorer so we have a little bit more real estate in here. So I have an idea that the error would happen here. So one way for me then to see how the application behaves would be to insert a so-called breakpoint. In order for me to do that, I have several options. One of them would be to press F9. The other one would be to press this gray column in here, and then I can press it again to remove it. And another one would be to right-click, choose breakpoint, and then choose insert a breakpoint. Once a breakpoint is put in there, as soon as the execution of my application hits that particular point, Visual Studio will take over and it will stop there, giving us an opportunity to inspect what the application is doing. So let's press Send Info. Now, because I have the breakpoint in here, the application will start in here, and I have an option to investigate all the variables that I have here. So I can see that I have some autos variable. So I have txt-data.text. I have the control itself, and I have sender and this. Those I'll call autos because those might be changed or might influence the outcome of the current line of code. Then I have locals. Locals would only show me the current object, will show me and the parameters of the method. So I can actually look into those and get more information. And the last one is actually watch. So inside the watch, I can put the variable I want to watch, and I can say which property I'm interested in. So I will be interested in the text property. And pressing enter, it will show me that this is an empty string. Another way to achieve the same thing without having to go into the watch or anything, it would be to go in here and see exactly that I have a value in there. Okay, so let's see what would happen. If I press now F10, it will take me to the next line of code. And if I press that again, it will show me, yes, we are going into throw new application exception. So I will press again F10. And what that will say, yeah, we have an exception. Do you want to continue? And if I say continue, my current execution will stop. So if I want to go back, I can just press the back button and then try again to press send info and see exactly the result. So I see it's still an empty string, so I haven't done anything. So of course, it will still crash. But now this time I want to avoid the crash. So what I do, I right click on the line that I want to jump to, and I would say set next statement. What that would effectively do will ignore the rest of the code and run only the information that I need. So now I'm back on the page, but without getting an error. Let's see what happens now if I press this hello world. So if I press hello world and send info, now we'll start here. It will show me that I have some value in it. This one, it's red now if you look in here, and the reason for this being red, it's because I've changed the data. So since the last time I've been here in my debugger, that was an empty string, now it's changed to something else. And the same would be here on the autos, because I just changed the value. So if I continue running the application, now I won't get any of the errors. So let's do that and just show you that this will now show you postback data hello world. Let's do that again. Let's press send info once more and see what else can we do with the breakpoint. So if we look at the breakpoint, it has some settings, and we can do actually some conditions in here. So one of the conditions I can put, I can say, you know what, I don't want you to stop every single time. I want you to stop only when text.data.text, it's an empty string. So let's do it like this. When that is empty string, I want you to stop here. Now, I can press again F10, and as you can see here, I have actually a plus on it, meaning that I have a condition, and it even tells me what the condition is. So let's run the application, and let's press send info a couple of times. As you can see, it doesn't stop, but all of a sudden when I have an empty string and I press send info, again, it will take me here and it will show me the data. I don't want to stop here. I would say set next statement, and then I would say continue. If we go back to Visual Studio, I can right click on that and I can change the conditions. So I can cancel this one, and I can add another condition that says I want to have a hit count. So my hit count would be, I would say 10. I would press close, and if I go and look at it, it says you are currently at hit count number 5, but when it would be 10, you would have to stop. So let's go back to our application and then choose hello world and then send info. It doesn't stop. I press again, it doesn't stop. I press again, it doesn't stop. So I do that 5 times, and then when it comes to number 10, it would say hit count is equal to 10. So then we are going to stop in here. This option is very useful, especially when you have a big chunk of data and you have something like a for loop, and you don't want to stay on every iteration. You want to stay only after a certain number of iterations in order for you to be able to get the information there. Of course, there is more to breakpoints than just what I show you here. So I would really encourage you to delve a little bit deeper into that in order to see what you can do with the breakpoints. Now that we are done talking about how we can create maintainable code, let's see how we can create reusable code. And the whole point of this discussion is actually to make sure that we understand what choices do we have when we start creating new controls or how we can reuse some of the code that we are writing. And for this purpose, I have created a simple contact us form inside our contact page. And in there I can put actually a name of the user and then some text like hello world. And then I'll press send, and this will actually show me that user TB said hello world. So it's a very simple contact form information. Let me show you how the code looks like for this one. So I have added on the existing contact page. So this is the code how it looked before up to this point. And what I added was this contact us part in here. So what we have a table where we have a name, and then we have a text box containing the txt name, and then we have another one called message, and then the text box called txt message. Then we have a button, and the button has the send text. When you press that one, the button send click method would be invoked. And we have as well a label called LBL output. So the code itself is as simple as it gets. If you invoke the btn send click, meaning that you click on the button send, then we are changing the text of the output to user said by using string.format method. So it's very simple. This is a very simple way to do that. Now, one of the things that I want to do, I realized that this name and message can be reused. So one of the things that I want to reuse it, for instance, is later on, if I want to edit either the name or the message or something, I just don't want to recreate this control over and over again, or those two controls to add them on a page. So I just use this one as a one single control. So the simplest way for us to do that is to actually go back into our Solution Explorer. And then if I right click on the project, I can say add, and then I can add a new item. And the item would be a user control. So if we look at the web, we have on the web forms, a web forms user control. And this one can have a name. So the name that I want to use for this one would be contact form.ASPX. So this is a simple control that I'm creating. When I create the control, I get almost the same thing as I got with a new page. So instead of an ASPX, I get an ASCX. And instead of the page directive, I have a control directive. But everything else, more or less, it's the same. So exactly the same discussion as we had before applies here. So now if I want to make this one a control, what I have to do is to take the contact ASPX from here, take the whole content of the table that is here, Control X, and then move it inside the control. And once I'm done with that, I have more or less a similar contract that I can start reusing inside my forms. Now that we have created a control, let's see how we can actually start using it. So of course, the easiest way would be to just take the control and put it in here in this page. But before we can do that, we need to register it. So if you remember, I mentioned that one of the preprocessor directives or page directives that we have available, it's called the register one. So on the register directive, we have actually the possibility to define a tag prefix. The tag prefix normally would be UC. That stands for user control. So it's something that I'm creating for myself. And then a tag name, you can choose whatever name you want in here, but I would recommend using the name of the control itself. So in our case would be contact form. So I know exactly which one I'm working with. And then I need to specify the source. So from which file do I want to receive that? And if I press equal, it will tell me which controls do I already have in my current folder. And the one that I'm interested in is the contact form ASCX. Once I have that, I can actually compile now the application. So I go to build and say build solution. So just make sure that everything works correctly. So no errors or anything. And once this is compiled, actually, yeah, we get 2 errors here. And the reason we got them, it's because we just removed the txt names and the txt message from the contact, and we put them inside the contact form ASCX. So we need to fix that. So let me go back to code in here, because this is where the error comes from. And instead of removing that, I would just comment out for the time being. So we get to see how we fix it once we are done with the user control. So coming back in here to the contact ASPX page, now I want to use the control. So what I have to do is just use UC and then colon, and then the name of that, which would be contact form. Now, there is a bit of an issue. Sometimes Visual Studio doesn't pick up that we got the changes, but what normally happens if you restart Visual Studio, then it will start picking up this change as well, meaning that next time when we want to use the same control, we will get IntelliSense with it as well. And I have to add run at equals server. If I forget that, then it will give me actually an error when I try to use it. So let me make sure that I copied correct information. So it's contact form, tag prefix UC. Let me put here contact form, and then I can add an ID to it if I want to use it later on inside my project. So I would say ID, it's a contact form and it's message. That would be the name of the control. So let's do another build. Just make sure that everything works now when we build the application. And if we run the application now, it should look exactly the same like it looked before we moved the data. Now, there is one single difference now. This one, message, if I press send in here, it won't show anything because once I remove the code, and two, the code is not there, actually is not yet implemented. So next, we are going to see how can we get this information from the control into the outside world. So in order to be able to communicate with this particular control, we'll need to add some properties to it. So we can go here, actually in the Solution Explorer, we can go to the control itself, and we can go to the CS file, and here we can add some public properties. So if the property is marked as public, it means that the property itself would be made available to the outside world. So let's do that. The first one we are creating, it's a property of type string, and we are going to call it name, because that was the first one. And then the second one would be a public property. So let me do the same, prop string, and then the name would be message, and that would be the property that I have in here. Now, when we do the page load, we can actually look inside here and get the information that we need. So one of the things we need to do is here, if is postback. So in case that this is happening to be a postback, then it means that we want to read the information from the controls and put it inside the properties. So what we have to do now, so if it's a postback, we will have to read the information from the control and put it into the variable. So name equals txt name.text and message equals txt message.text. Okay, and if it's not a postback, maybe we want to send some information, so we want to have something already inside the control, then we can do like this. Else, because it's not a postback, then we will do the reverse. So I will copy these two lines, but I will reverse the order of the operation. So I would say txt name.text equals name, and txt message.text equals message. Okay, now that we added the properties, we can start using them. So I can go back into the contact ASPX, and just to show you that this one works, now I can say name. It still doesn't throw because it's not compiled, but I can say name equals TB. So by default, whenever I start this one, I will have the value TB in there. And then inside the code behind, I can go back in here now and say label output.text. I don't have the txt name, but instead I have the cf message, and I have two properties, one called name and the other one is cf message called message. And let's compile the application. Everything seems to be okay, so run it and see if now we have it working. And if everything works okay, I should have the name already filled with the value TB, and it just waits for me to put something like a message in here. So I would say this is my message. And I will say send. So TB said this is my message. I can even change the name here, and I would say someone, and then I'll call send and say user someone said this is my message. Next, let's discuss about how state is managed inside ASP.NET Web Forms applications. So if you remember, we had a discussion about the page lifecycle a little bit earlier, and we had three different phases: the init phase, the load phase, and the render phase. Now, I mentioned then that I will take this discussion up again in order to introduce the notion of the state and how this one is actually managed in this context. So when we make a normal request, so that means the very first get to a page, in the render phase we have two more methods that are going to get called. One of them is called save state. So save state would actually go and get all the information from every single control that is on that particular page, and it will encode it into a variable called view state, and it will send it to that particular page. When all the information got acquired, then the save state complete event will get triggered, and then the render is going to happen. Now, when we are going to go back on the page and press a submit button or do a postback, then the init phase would get as well augmented with more methods. So after the all pre-init, init, and init complete, we have a load state. What load state will do would actually go back and take this view state information and recreate the original state of the page, meaning that whatever we've changed, it doesn't add anything or it doesn't change anything. So it only loads the state as it was when we rendered the page. And then we'll start processing all the post data, meaning that all the data that we were sending inside the page, the buttons that we might press or text boxes that we have changed, and so on. And then it comes the load phase. So we do preload and load. And after the preload and load, we are going to try a second process of post data. And the second process of post data happens because sometimes you might have dynamic controls. So you won't see that normally happening in a normal page, only on a page that controls get automatically or dynamically created for that particular page. And after that, we are going to have change events. So if I change like a drop-down list, or if I change the text inside the text box, or if I change a checkbox value and so on, all those will generate those change events. And then last but not least, I have a postback event. So the postback event, it means that I would be able to get the button click event or whatever. So this would be the last one to happen. And then we have the load complete, and then we go back again on the render phase where we'll have again the save state and save state complete, meaning that we are going to save the new look and feel or the new state of the page as it looks right now. Every application today needs to store the data somewhere, and one of the most popular technologies in Microsoft world is SQL Server. So let's see a little bit what is SQL Server and how we can work with it. SQL Server is a relational database management system, meaning that the data stored inside the database has some relation with one another, so we can have different kind of organizations. If we look inside the server itself, we are going to see that the data is organized first in databases. So database, it's a big container containing a lot of tables. So every table contains data that is related, mostly pertaining to one single entity. And inside the table, what we have columns. So the column, it will define the type of data that we want to store in that particular column. And then the data itself is stored in rows. So if we look at one big database, we would have several tables, and then normally the tables have some kind of relationship between them, and then inside that tables data is organized in rows and columns. Now, when we work with SQL Server, we have 4 different editions, or actually 5 if we really want to count LocalDB. The first one is Enterprise, and the second one is Developer. Both of them are exactly the same in terms of what they are offering, with one very important difference. Developer edition, it's only intended for non-production use. So you are not licensed to use that for production systems. So you only have to use that when you develop your applications. And this is the biggest version that contains all the features that Microsoft would ever thought in including in that particular database. Then we have the Standard Edition. Standard Edition is a little limited in the amount of data that it can save, in the amount of things that it can do, in the replications and all those things. It's much cheaper than the Enterprise Edition. It has support for production use, but again, it's very limited in its use. And then we have Express. Express Edition of SQL Server. It's a very lightweight version. It supports databases only up to 10 gigabytes. It has a lot of features stripped down, so it doesn't have the full support of standard. But maybe for most applications, this is enough. They can just go away and do what they need with Express Edition. Now, the other thing with Express Edition is that it's free, so you don't have to pay for it to use it. But again, you have a lot of limitations. So depending on what your application needs, you can use that. And as you can see here, it's mentioned LocalDB as well. LocalDB is a special version of Express Edition, with the only difference that when you run that, you don't have a database engine installed on your machine. The database engine would run together with your application. So this runs from inside your application. Now, let's have a look at the site where you can find SQL Server and where you can install it. So, and here we get the information about different aspects of SQL Server, like the overview. We can look at different comparisons, what SQL Server can do compared with other platforms, and what exactly should you look, for instance, like in different versions, which is what is supported, what is not supported. On that, we can look at different editions. So based on those editions, we get an information about what is supported and not. And then based on that, we can decide if that's something we want to use or not in our applications. We have information about the pricing as well, so we can look at that. But the most important part, actually, I think it's the fact that you can just try SQL Server here or here. If I press any of them, it would give me an option to download SQL Server. I can download the free trial, install it on my machine and see exactly how this would work. Or I can download some specialized edition. So developer, it's free. Again, I don't have to pay for it, but I am not allowed to use it in production. If I want to use something in production and I don't want to pay for the database, I can use SQL Server 2017, but then it's again the amount of features that are available, it's very limited. However, inside our course, we are going to use LocalDB, which comes installed automatically when we install Visual Studio 2019. So now we are back in Visual Studio, and what we want to do, we want to create a database. And as I mentioned, we already have installed on our machine the LocalDB version of SQL Server. And when we do that, we have different options. So one option would be to go in the solution and inside the app data, which if you remember, I mentioned in the first module that this is the one where we are putting the databases and it's the only one we have the rights. So I can go in here and say add new item. When I'm looking at the kind of new items that I can add, I can say I want to add a data. And the kind of data I want to add, it's a SQL Server database. However, keep in mind that this database, it's actually a database that is only local to my application. So this won't be a database generally available for everyone on this machine. So let's call that messagedb.mdf. I would say add, and this will create automatically an empty database file for me that I can start working with. Now, again, this is local. If I want to create a database that is available throughout the whole machine, so maybe different projects want to have access to it, the way I can do it, I can go in here and I can create a new data connection. I can right click in here and I can say create new SQL Server database. And when I say create a new SQL Server database, as the server name, I need to use the localDB /MS SQL localDB. And the database name would be something like the demo DB. So this is another way to create a database. And what that will do will create a database locally on this machine that can be accessed by all the applications. However, let's go back and look at the database that we just created for our own application. So this is a simple database. It has no tables in there. And one thing that we are interested in actually here is to see the connection string. So the way we do that, we right click on the name of the database and choose properties. And inside the properties, we have connection strings. I can click on that, say Control A and then Control C. So what that does for me, it copies the connection string. And then I can take the connection string and I can put it inside my web config file. So right after the configuration, I can go and say connection strings, and then I can add the first connection string. So one of them would be add, and then the connection string would be the name. Actually, let's start with the name, messagedb, and then the connection string itself will be the one that we just copied from the server. We need to clean it up a little bit. We need to remove some of the double quotes that we have in there. So we keep it clean, and then we have this as our connection string. As you can see, this is pretty long. So one way to actually short that one and make it not dependent on the absolute folder on our machine, we can do like this. We can say instead of the whole long folder, we can say data directory. And that would actually point to exactly the same folder inside our current application. One more thing we need to add is information about the provider. So what we are going to do, we are going to include the provider name. And as a provider name, we are going to use system.data.sql client. Once we say that and we save it, if we go back to Server Explorer now will contain information about our message DB. So I can double click on that, it does connect to the database, and now we can start working with it. So the very first thing I want to do is actually to create a new table. So let's create a table. Let's call that table messages, because in this table we are going to save all the messages. Our primary key would be as well an identity field, meaning that we are going to be able to identify uniquely our elements on that. We are going to add name, and name would be a var char maximum 50, so we don't want to do anything bigger than that, and we do a not null, so at least we are forcing you to install a name in here, and the message would be a var char maximum, var char of maximum, and that would allow null, so we don't have to specify anything in that. Once we've done that, I can just press update in here. This will prepare an update script. And if I run update database, it will send the information to the database. And once that is successfully run, we can see the green indicator here. Going back to the Server Explorer and refreshing the page, we get to see that now we have a table as well. So now that we have a database, let's start using it. And what I want to do with it, actually, I want to use it on our contact ASPX, and I want to save all the messages that get sent to our application. So let's see how we can do that. The first thing we need to do is to find the connection string. So what I need to do, I say var connection string, and I need to read that connection string from the configuration. So that would be configuration manager. The configuration manager class, it's part of the system.configuration. So if I press Ctrl dot after configuration manager, it will show me a list where I can find this information. So I would press dot, and then it has a property, this configuration manager, called connection strings. Connection strings is a dictionary, so I can either use the index of it or I can use the name. And if you remember, the name actually it's in web config and it's called message DB. So let me copy that and put it in here. And this is a connection string object, so it means it contains both the name, the provider, and the connection string. So what I want to read from it, it's the connection string itself. Once I got that, I need to use this connection string to read something to open a database connection. But before I do that, let me do something else. I want to create a insert statement. So that one would be the one used to insert stuff into the database. And it's pretty simple. It's insert into, and the name of the table was messages. And I want to insert only the name and the message. I don't want to insert the ID because the ID being an identity field, it would be automatically generated. And then the values for it would be, again, a parameter called name and another parameter called message. So with this one, now we have a connection string and we have a statement that we can run into the database. Next thing we need, it's a connection. So what I would say now, it's using var SQL connection equals new SQL connection. And again, SQL connection, it's not in scope. So to bring it in scope, I press Ctrl dot after it, and it recommends me to use system.sql client, and I choose OK. And the SQL connection takes as a parameter the connection string. So we are going to use the connection string we just defined a little bit earlier. Then inside that using, first we are saying SQL connection.open, because we need to open the database in order to work with it. And the next thing we do is do another using, and in this case we are going to create a SQL command, var SQL command equal new SQL command, and the command should take a statement, and the insert, we are going to use the insert statement into that as a parameter, And it takes a second parameter, which is the connection that we want to use, which is our SQL connection object. So again, we have now using this one. If you notice, I mentioned here @name and @message. Those are two parameters. And the reason I want to use parameters is because I want to avoid something called SQL injection. And in order to avoid that, it is recommended that you use SQL parameters and not build dynamically the strings. So in order to have the parameters, I would have to do something like SQL command.parameters.add parameter with value. The name of the parameter is name. And the value would be the one that we get from the contact form user control CF message dot name. And then we will do the same for the message. So Control C, Control V, and then the message will take the value from the message. One thing we need to do now, after we put that, we need to run the command itself. So what we need to run is SQL command dot execute non-query. This is not a query, so this is not expected to return any data. What it will return is actually value number 1, because that's how many rows we have changed. Once this is done, we're actually ready to run our application and see what would happen. So I'm starting the application. And once inside the contact page, I can put in here a message. So I would call that first message. And I will press send. If everything worked okay, we get to see nothing. So if you want to see what did we get, we have to close the application, go back to Server Explorer, look into the database, and then list the tables. And if I right-click on the messages table, I can see the table data. And if everything worked okay, we have the name and the message as the first message. Now that we saved the data into the database from our contact form, let's see how we can actually show the data on the contact form. So I'll go back here, and instead of the label, I will use something else. And what I would like to use actually, it's a list view. So I'm going here, I'm expanding data, and inside the data I have a list view, which I'm dropping in here. And I can give it a name. So the name would be LV messages, for instance. Okay. There is one anchor here right under ASP that will allow me to configure this. So instead of going and doing everything manually, I can just press on this one and then configure the list view. I have no data source, so I start by configuring a new data source. I know that I have a SQL database. I will call the data source message DS. So it's the data source for the messages. I press OK, and it will ask me if I want to use an existing connection string, which I want because it's already connected to the right database. I would say next, and it will ask me which tables do I want to use or anything else. Because I have only one table, that's why it only shows me messages. Another thing that I could do here, I can go on the advanced and say I want to generate insert, update, and delete statements as well, because I want to make sure that I can insert, update, and delete data from this particular list view that I'm going to generate. Saying next, I can test the query. I see that I have one name and message in the database. And if I press finish, it will configure for me the list view to use a data source. And I have a data source object called message.ds. Now I want to configure the list view as well. And I have several choices. One of them is, how do I want to show the data? Do I want to show it as a grid? Do I want to show it as a tile? Do I want to show it as a bulleted list, flow, single row? And if I want to use different colors. So I would go with grid because it's the simplest one. We don't really care about the layout at the moment. I just want to show you how the data is going to look. And then if we want to use inserting and deleting of the data. So I use enable editing, inserting, and deleting here. If I have too much data, I can use paging as well. So it tells me what do I want. I want a numeric pager or next previous, but I will just ignore it for the time being because we really don't need this one. And if I press OK, my list view would explode and it will have a lot of templates automatically created in it where I can start using. So I have one template called alternating item template. That would be for every other item. So if you remember when I showed you the layout that I want to use, I had one color for the first element and then a different color for the second and then the same color for the first and fourth and so on. So alternating item template. One thing that I want to remove everywhere, it's the ID. So I will do that. And bear with me for 1 minute. And the reason I remove the ID everywhere is because list view by default, it doesn't allow me to not use the ID. And I don't really want to show the ID. I don't want to work with the ID. It's something that has to do with how my data is represented internally. So let me show you how it looks right now. So as you can see, I forgot to actually remove label output from the code. I have here that one. So just remove this one and then try again. And once this is done, I can actually go in here and use the insert. And I would say tb2 other message and press insert. And then I got another message in the database. If I press contact, so I will do a refresh, it will just refresh the page. So one other thing that I want to show you is how we can tie this together with the user control that we created a little bit earlier. So what I want to do, I want to press a message here and see if it still works. Hello world again. And then I can press send, and apparently it doesn't work. In fact, it does work. So if I press the contact page again, it will do a refresh of the page and it will show me the result. The reason actually it doesn't show me that is because I'm not binding the data when it should. So what it happens actually behind the curtains is that my application is actually going to show the data before it has all the data. So one of the things that I need to do, because this is happening on button send click, I want to go in here and say protected void page pre-render. So before we render the page, I want to actually say object sender and then event args e. What I want to do in here, I want to say please the list view messages data bind. So if I do that now, that would automatically refresh the content after the update is done. So let's do that and see exactly how it looks like. If I run the application, it shows here and say, does it work? If I press send, now it should show it here. Now, of course, we already have an insert here, so this one now becomes a moot point. So what I want to do is replace that with this control. So let me show you how this can be done. One of the things you might have noticed is that this one was a little bit off because I forgot to remove a TD in there. But then I want to remove as well the text box in here. So let me show you how I do that. I would go in here and I would say I want to use the user control that we just created called the contact form. I want to give it an ID. When you use it like this, you need to give it an ID. And the ID would be contact form the insert. So I would say contact form insert. And then I need to do a name. So I want to use the name. And I want to bind it to the name property exactly as it is done in here. And actually, it should be like this. And then I want to do the same with the message, which should be bind like this here. Okay. So I will put this one in here now. And then I need to say run at server, because without it, if you remember, this one won't work. So I'm closing this one. Let me see that I'm doing the right thing here. I put this in the right element. So this would be a TD in here and a TD in here like this. So I'm putting that in a element. I remove the other two. And one more thing I can do, I can go above this one and then I can actually remove this and even the send button, because I don't need any of them as I have everything now in my list view. So if I do a run again, I do have an error, and the error comes from the fact that I'm now reading the CF message in order to do the insert. Again, using the list view, I don't need to do the insert manually. So let me just comment this out and try again once more. And now I can see that the insert button looks a bit different. I would say TB, does it work again? And pressing insert, it should just add it without any issue. And of course, the same can be done for the edit box. And this is how we add the edit support. So we are going back to the insert template. We are going to copy the content of that insert template and add it to the edit template. And in theory, it should be as simple as that. But if I run it now, it won't work for one simple reason, because we do not send the data back to the server. So what I need to do in here, in my contact as well, I need to do a page pre-render and call the data bind. So I would go in here and then I would copy this code from here. And let me add it in this one in here. So it's the name of the message. And what I have to do actually, it's just copy those two lines from here. Control X and Control V. We don't need the else branch. And now when we run the application, we are going to see that we get as well support for editing inside our form. So I can put edit, I can say TB2, 3, so we see that it's a different one, and pressing save it would do TB2, 3. If I press contact again to do a refresh from the database, we see that those got actually saved into the database. And I can edit every single one of them, I can say update, and of course if I want to delete something, I just press delete and it's gone.